Question number 24. Using a minus b whole cube equal to a cube minus b cube minus 3ab into a minus b. Take the correct of these when x equal to p raised to 1 by 3 minus p raised to minus 1 by 3. So these are the options A, B, C and D, and in all we can see that in other than option number D, A, B, C we have to find the value of x cube plus 3x. So let us see, we'll find the value of x cube plus 3x, we'll check which of these three is possible. If it is not possible, then option D will be the correct answer. So let us start doing question number 24. So solving 24, solution 24, x equal to here, x equal to p raised to 1 by 3 minus p raised to minus 1 by 3, and we need to find the value of x cube plus 3x. So first of all we'll find x cube, therefore x cube equal to p raised to 1 by 3 minus p raised to minus 1 by 3 whole cube, and we'll get therefore x cube equal to, now we'll do is we'll apply this formula a cube minus b cube minus 3ab into a minus b. So we'll be getting equal to a cube, that is p 1 by 3 cube, then minus b cube, this is our b. What is our b? This is our b. So minus p raised to minus 1 by 3 cube. So this is a cube minus b cube, then minus 3ab, minus 3 p 1 by 3 into p raised to minus 1 by 3. So this is minus 3ab into a minus b, that is p raised to 1 by 3 minus p raised to minus 1 by 3, and therefore we'll be getting therefore x cube equal to this, we know that a raised to m raised to n is a raised to mn, so we'll be getting here this 3 and this 3 will be cancelled out, here also 3 and 3 will be cancelled out, so we'll be getting here this will become p minus p raised to minus 1. So this is what we'll get here, p minus p raised to minus 1, then minus 3 into, this will become p raised to 1 by 3. So when base is same, we can add the power 1 by 3 minus 1 by 3, that is p raised to 0. So it will become minus 3 into p raised to 1 by 3 minus 1 by 3, and into we are having p raised to 1 by 3 minus p raised to minus 1 by 3. So we can replace this with the value of x. So into x. So therefore we can write this as x cube equal to p minus 1 by p minus 3 into, now this will become 0 p raised to 0 into x. So we will be getting therefore x cube equal to p minus 1 by p minus 3x, and now we'll transfer minus 3x to the left hand side. Why? Because we need the value of x cube plus 3x. So therefore x cube plus 3x equal to p minus 1 by p. So we have obtained the value of x cube plus 3x. Now let us see which one of these is true. First one is p plus 1 by p, second one is p minus 1 by p, and third one is p plus 1, and fourth one D, none of these. So the correct option will be B, because we are having to the right hand side p minus 1 by p. So that is what we'll write. Therefore correct option is B. So this is our answer of question number 24. So with this, question number 24 is complete. Question number 25. On simplification, 1 over 1 plus a raised to m minus n plus a raised to m minus p plus 1 over 1 plus a raised to n minus m plus a raised to n minus p plus 1 over 1 plus a raised to p minus m plus a raised to p minus n is equal to option A 0, option B A, option C 1, option D 1 by A. So let us solve question number 25. So solution 25, 1 by 1 plus a raised to m minus n plus a raised to m minus p plus 1 over 1 plus a raised to n minus m plus a raised to n minus p plus 1 over 1 plus a raised to p minus m plus a raised to p minus n. So now we will simplify this further. So what we are going to do in this is we will see the first one. In the denominator we are having second term and third term, both in both the base is a and also the power is here m minus and here it is m minus p. That means the first term we can write as a, in terms of a, as a raised to m minus m, because m minus m is 0, and also in that case we will be getting the in the index the first number as m, because the if you see the index, it is made of two numbers and they are separating each other, and the first number is always m here, and here see that in the second one, in the denominator of second term and third term, the number is n, and in third term, in the third number, you can see that in the denominator, second and third term, both the indices, the first number is p. So we will be trying to write in that form. So equal to, we can rewrite this one as 1 over 1 can be written as a raised to m minus m, because we know that any number raised to 0 is 1. So plus a raised to m minus n plus a raised to m minus p. So why we have written this one as a raised to m minus n? Because seeing the second and third number. So plus, same way in the second number, in the denominator we will see that this one we can write in terms of a, as because a raised to 0 is 1. So 1 we can write as a raised to 0, and 0 we can write as n minus n. Why n minus n? Because seeing the second and third term here. In second term, the in the index you can see that the numbers are n minus n and m being separating each other. Here n and p are separating each other. The same order, if you follow that, one should be written as n minus something, because but the power of a is here 0, so it should be obviously n minus n. So a raised to n minus n plus a raised to n minus m plus a raised to n minus p. So we have written the second one, and let us now write the third one in the same way, plus 1 over, this one can be written as a raised to p minus p. How? Seeing the second and the third term. Then plus a raised to p minus m plus a raised to p minus n. Now solving this further, equal to 1 over, first one we can write as a raised to m over a raised to m, because we know that a raised to m minus n is a raised to m over a raised to n. So plus, same way here, then applying the formula again, a raised to m over a raised to p. So same way we'll do the second one, plus 1 over, this can be written as a raised to n over a raised to n plus a raised to n over a raised to m, and plus a raised to n over a raised to p. Then plus, for third number, we can write this as a raised to p over a raised to p plus a raised to p over a raised to m plus a raised to p over a raised to n, equal to, now what we can see that in the denominator it says a raised to m, a raised to m, a raised to m is common, so that we can take it out, and what we will be getting in that case is 1 by a raised to m into 1 over, so what will remain here is 1 by a raised to m plus 1 by a raised to n plus 1 by a raised to p. Same way we can do in the second number also. We can take out 1 by we can take out a raised to n common in the denominator. So what we'll be getting here is 1 by a raised to n plus 1 by a raised to n into become 1, and we'll be getting here because we have taken this a raised to n common, so remaining will be 1 by a raised to n plus 1 by a raised to m plus 1 by a raised to p. Now for the third one, plus here we can take out a raised to p common, so 1 by a raised to p into, in the denominator we will be having 1 by a raised to p plus 1 by a raised to m plus 1 by a raised to n. Now we'll solve this further and see what we can get on solving it further. Now before we go in the next step, let us see the earlier step. Here we can see that in we are having the three numbers 1, 2 and 3. In all, if you see it here, what is common? This is common, 1 by a raised to m plus 1 over 1 by a raised to m plus 1 by a raised to n plus 1 by a raised to p. Here also you can see that the same thing, same quantities here. Here you can see that there is no difference because we know that in addition and addition is commutative. So here we can write this 1 by a raised to n plus 1 by a raised to m plus 1 by a raised to p. We can just, if we interchange this, we'll get this only. So there is no change between 1 and 2. So same quantity we are getting. And we see the third one. Third one also we can see that what we are having is here 1 by a raised to p plus 1 by a raised to m plus 1 by a raised to n. So in all the three numbers, this quantity is common. So we can write in the next step, that is remaining will be 1 by a raised to m plus 1 by a raised to n plus 1 by a raised to p. So first let us write down this. So what we are getting is equal to 1 over 1 by a raised to m plus 1 by a raised to n plus 1 by a raised to p. 1 by a raised to m plus 1 by a raised to n plus 1 by a raised to p. And remaining will be this much. From the three terms we have taken this common, so the remaining will be 1 by a raised to m plus 1 by a raised to n plus 1 by a raised to p. So 1 by a raised to m plus 1 by a raised to n plus 1 by a raised to p. And it's very clear that these two can be cancelled out, and so the final answer will be 1. Therefore correct option will be, correct option is, so let us see what is the correct option. So we'll see what is the correct option in this case. Now we were doing question number 5, so the options are A0, B, A, C1 and D1 by A. So the correct option is what we are getting 1. So the correct option is C. So the correct option is C, that is 1. So with this question number 25 is complete. Now let us do question number 26 one. It's a very simple one. How we can do question number 26? So solving 26, x raised to a over x raised to b, and overall power is a plus b multiplied by x raised to b over x raised to c. Overall power is b plus c into x raised to c over x raised to a, and the overall power is c plus a. And we know that a raised to m over a raised to n is equal to a raised to m minus n. That means where the base is same and the numbers are dividing, you can subtract the power. So we'll be getting this as equal to x raised to a minus b, and outside power is a plus b into x raised to b minus c, and outside power is b plus c, into x raised to c plus minus a, because they are dividing, and outside power is c plus a. So equal to, now we know that a raised to m, but we know we are having this rule, that is a raised to m raised to n is equal to a raised to mn. So that we'll apply, and we'll be getting this as equal to x into a minus b to a plus b, that is a square minus b square, into x raised to b minus c to b plus c, that is b square minus c square, into x raised to c minus a into c plus a, that is c square minus a square. And we know that whenever the bases are same, we can add the powers. So this will become x raised to a square minus b square plus b square minus c square plus c square minus a square. And now we can see that minus b square plus b square will cancel each other, a square and minus a square cancelling each other, minus c square plus c square will cancel each other, and what we will be getting is equal to x raised to 0. And what is x raised to 0? Any number raised to 0 is 1. So this will be equal to 1. So this x raised to 0, because all numbers are being cancelled out. So x raised to 0 equal to 1. Why? Because a raised to 0 equal to 1 for any real number a. Now we'll be solving this further. Um, let us see, for this let us go in the options. Option A is 1, option B is 0, option C is 2, option D is 1. So what is the correct option? Therefore we can say that the correct option is A. So our answer is A, 1. Therefore correct option is A, 1. So with this question number 26 is complete. And as far as question number 27 is concerned, question number 27, you can see that it is same as this question we have done 24th one. So this one we will be doing for self trial. So you will be trying on your own. Question number 27 you will try on your own, and there is no difference between this one and 24th one. So do it in the same way as we have done question number 24. So question number 27 you will be doing on your own. Now solving question number 28. If a raised to x equal to b, b raised to y equal to c, c raised to z equal to a, then x, y, z is. So we'll be solving question number 28. Solution 28. A raised to x equal to b. We are having a raised to x equal to b, and b raised to y equal to c. So let this be 1 and this be 2. And c raised to z equal to a, and let this be 3. So what we'll be doing, that we'll be putting 1 into, so putting 1 into, so in place of b, this b will be putting this value, that is a raised to x. So putting 1 into, will be getting, in place of b will be putting a raised to x. So a raised to x raised to y equal to c, and suppose this is 4. Now what we'll do is that we'll put 4 in 3, putting 4 in 3. So in place of c, what we'll put, a raised to, this can be written as a raised to xy, that is a raised to xy, because when base is same and the powers are in the form of a raised to m raised to n, we can, that is a raised to mn. So this will become a raised to xy, and outside power is, that is z. So z. Simply what we have done, we have replaced this c with this value. So we are getting here a raised to xy raised to z equal to a. So simplifying this, we will be getting the same result, that is a raised to m raised to n is equal to a raised to mn. So therefore a raised to xyz equal to a, and a can be done, this can be done as, therefore a raised to xyz equal to a raised to 1, because a raised to 1 is a, and we know that whenever base are same, then the exponents are also equal, or the powers are also equal. So what we will be getting here, x, y, z will be equal to 1. Therefore, x, y, z equal to 1. And what we can say, therefore the correct option is A1. Therefore, correct option is A1. Correct option is A1. So with this, question number 28 is complete. Now let us go in this question number 29. If you see question number 29 and question number 23, they are identical. Same way you can solve it. There is no difference in the way of solving it. And so this question number 29 will be for self trial. And how you have to complete it, you have to do in the same way as we have done this question number 23. So what we'll be doing here, this will become x raised to the power of a minus b, then multiply with a square plus ab plus b square. So we'll be getting here x raised to a cube minus b cube, and this will become x raised to b cube minus c cube, and this will become x raised to c cube minus a cube, and then all the terms in the exponent part will be cancelling each other, and we'll be getting x raised to 0. And what is x raised to 0? 1. So the answer of this will be 1. So you'll be doing question number 29 on your own. Very simple way of doing it. Now let us do question number 30. If 2x equal to 3y equal to 6z, then 1 by x plus 1 by y plus 1 by z is. So here, solving now question number 30. Here 2x equal to 3y equal to 6z, and we have to find the value of 1 by x plus 1 by y plus 1 by z equal to. Now to apply the this form, what we'll do, we'll multiply this uh, the third number containing z, numerator and denominator both with 6, and this one, first one will multiply with 2, and second one will multiply with 3. Multiply and dividing with 3, here also multiply and dividing with 2. So this can be written as 2 by 2x plus 3 by 3y plus 6 by 6z. Multiply and dividing by 6, multiply and dividing by 3, multiply and dividing by 2. Why? So that we can use this result. So equal to, this can be written as 2 over, we can replace 2x with 6z plus 3 by 3y can be written as 6z, and plus 6 by, there is no need to change this, so it is 6z. And now denominator same, so we can add the numerator. 3 plus 2 is uh, 5, 5 plus 6 is 11. So what we are getting is here is 11 by 6z. So this is our answer, final answer, and we can see that there is no option which is giving 11 by 6z. So our answer in this case will be none of these. So therefore we can say that, therefore correct option is D, that is none of these. So this is the answer of question number 30. Now let us do one extra question, question number 18. The value of square root of 6 plus square root of 6 plus square root of 6 plus so on till infinity. So solving this question number 18, so solution 18, we'll take, because we do not know the value of this, so let us take it as 6 plus square root of 6 plus square root of 6 plus so on, there is still infinity. And so let this be equal to, let x equal to this. Now if you see very carefully, then if you only see this portion, this is looking exactly like x only. So there is no difference between this and x which we have taken. So we can replace this whole portion with our x. So therefore x equal to square root of 6 plus x. Now squaring both sides, what we will be having is x square equal to 6 plus x. Bringing all the terms one side, we will be getting x square minus x minus 6 equal to 0. Now this is a quadratic equation, and we can solve it by splitting the middle term. So we can write it as x square minus 3x plus 2x minus 6 equal to 0, because minus 3 into 2 is minus 6 and minus 3 plus 2 is minus 1. So it is, the splitting is correct. So we can take out x from the first two terms. X into x minus 3 will be getting plus 2 from the third and fourth term. So remaining will be 2 into x minus 3 equal to 0. And now we can take out from these two x minus 3 common, into x plus 2 equal to 0. So what we are going to get is, therefore x equal to 3 or x equal to minus 2. But if you see here, there is outside the square root there is no negative sign, and the numbers inside the square root are all positive. So x equal to minus 2 is not possible. By definition of x, x it x equal to minus 2 is not possible, is not possible. Therefore the correct answer is, therefore x equal to 3, that is the value of this whole is equal to how much? 3. So this is the answer of question number 18, and with this the topic of indices also complete.